Hello, grade 8 students. In this lecture, I'm going to start with our new lesson for this year that talks about powers or exponents. So let us first of all list our objectives. First of all, we're going to learn what's the meaning of the power from the notation a to the power n. Then we are going to write a multiplication sentence in power form and vice versa. Then we're going to calculate different powers using, of course, the rules of powers. Then we have the powers of 10. How can we perform operations and rules of powers on powers of 10? We're going also to recognize the form of a number where it's written in scientific notation. Then we're going to write a decimal number in expanded form using powers of 10. Then, of course, applying pemdas and calculations on numerical expressions. And at last, we're going to simplify fractions using rules of powers. Let us first remember together what's the meaning of power. So the power is where I have the base, which is n, the exponent, which is n. So suppose we have 10 to the power 9, 10 is called the base and 9 is called the exponent. So this is called 10 to the power of 9. Also, if we have 2 to the power 3, we say it's 2 cubed. And if it's to the power 2, we say 2 squared. So this is a quick revision for the things that you have learned before. Now, how can I write a multiplication sentence in power form and vice versa? When I say it's a to the power n, well, power, it's the repetition of multiplication. So it's a times a times a times a n times. So if I have, for example, as you can see here, 2 times 2 times 2 times 2 times 2, it's 2 to the power 5 because it's 2 multiplied by itself 5 times. So the base is the number repeated. The power or the exponent, it's how many times this number is multiplied by itself. So let us take a quick examples. If we have 7 to the power 2 or 7 squared, it's 7 times 7, which is 49. 10 to the power 6, it's 10 multiplied by itself 6 times, so it's 1 million. Now I'm going to solve some of these powers, but of course I advise you to pause this video, try to solve them on a scratch of paper, and then check your answers. Then you can play the video and check your answers. Of course, I'm going to solve some of these. So if we have 2 to the power 1, it's 2. If we have 3 to the power 3, it's 3 times 3 times 3 times 3, which is 27. 0 to the power 82, so 0 to the power anything, it's 0. 10 to the power 7, you can do this mentally because when I have 10 to the power 7, it means I have 7 zeros. 8 to the power 1, it never changes because it's 8, and so on. 10 to the power 4, it's 10,000. 4 squared is 16. 100 to the power 6, it's 100 times 100 multiplied by itself 6 times. 9 to the power 2, it's 9 times 9, which is 81, and so on. Let me continue. Those are the important ones. So 0 to the power 20 is 0, and so on. You can check your answers here because we have a lot of examples. Let us remember together the rules of powers. So if we have a to the power of m times a to the power of n. So here we have the same base, which is a. In this case, we keep the same base and we add the exponents. Whether I have them the same or not, we keep the base and we add the exponent. If we have a over b to the power n, that means I can distribute the exponent for both a and b. A to the power m to the power n, in this case we keep the base and we multiply the exponent. A times b to the power n, you can distribute the exponent for a and b, so it's an times bn, only if you have multiplication. Please pay attention to this rule very well. An over am, you subtract the exponent, so it's an minus m, because this is division. And if you have a minus n, this is not, that doesn't mean that this number is a negative number. It's only negative exponent. So if you have negative exponent in the numerator, you just take it down, so it becomes 1 over an. A to the power 1, it's a, and a to the power 0 equals 1. So whatever you have in a, whatever you have power 0, it's 1. Let us try to solve some exercises. So 2 to the power 3 times 2 to the power 5. As you can see here, we have the same base, so we just add the exponent, so it's 2 to the power 8. Also 5 times 5 to the power 4, so you know that if I don't have a power, that's power 1. So you add the exponent, this is 5 over 5. 5 to the power 5, sorry. Here we have 7 to the power 4 over 9 to the power 4, so I can put them in parentheses if I want. In this case here, we can distribute the power only because I have multiplication in the middle. So here we have also 2 to the power 3 to the power 5, so we multiply the exponent. This is based on this rule. And if we have the same base, we just subtract the exponent. So 13 minus 8, it's 5. I want you to pay attention here when you have minus 3 to the power 2. So it's like minus 3 times minus 3, which is 9. So if you have n to the power n, where n is even, you can get rid of the minus. So it's directly 9. But if you have an exponent which is odd, the minus will remain as it is. And now we're going to talk about the scientific notation. How can I write a number in scientific notation? So writing it in scientific notation, it's writing it in the form a times 10 to the power m, where a is a whole number between 1 and 10. So the 1 is included, but the 10 is not included. So it should be only one digit. It could be a decimal number, but only in the whole part we have one digit, times 10 to the power m. M could be any number, positive or negative. Here, as you can see, we have 973. Okay, 973, it's written as 9.73 times 10 to the power 2. Why? Because I just moved the point 2 times to the left, so it's 9.73 times 10 to the power 2. 49.12, it's not written in the scientific notation because 49, it's a whole number composed of 2 digits, and I wanted only one digit, so I have to move the point 1 time to the left. So it becomes 4.912 times 10. Why times 10 to the power 1? Because I just moved the point 1 time to the left. Okay, now we have 7. 7, it's already in the scientific notation because 7 times 10 to the power 0, it's 7. So this is the scientific notation of 7. 290,000. So the point is here, I have to go back 1, 2, 3, 4, 5. So 2.9 times 10 to the power 5 because I moved 5 times to the left. 0.053, this is not in the scientific notation because 0 cannot be, it cannot be 0. So it should be any number from 1 and above. So I have to move the point now 2 times to the right. So it becomes 5.3 times 10 to the power minus 2. Why times 10 to the power minus 2? Because I moved to the right. And the last example, 0.00008. I have to move the point 5 times to the right. So it becomes 8 times 10 to the power minus 5. Now writing a decimal number in expanded form using powers of 10. So to expand a number, we need to use the powers of 10. If it's in the whole part, we start the ones 10 to the power 0, tens 10 to the power 1, hundreds 10 to the power 2, and so on. In the decimal parts, you know that the decimal parts start with the tenths, which is 10 to the power minus 1. The hundreds is 10 to the power minus 2, and so on. How did I know this? Do you still remember that the tenths are 1 over, let me just write it for you. It's 1 over 10. So when the 10 goes up, it's 10 to the power minus 1. The 100, it's 1 10 to the power 2. So when it goes up, it becomes 10 to the power minus 2. So that's why, sorry, this is 2. Okay. That's why the tenths is 10 to the power minus 1, and the hundredths is 10 to the power minus 2, and the thousandths is 10 to the power minus 3. So in this number, to 2953, actually we don't have decimal part. So it's 3 times 10 to the power 0 plus 5 times 10 to the power 1 plus 9 times 10 to the power 2 plus 2 times 10 to the power 3. So I just pass them digit by digit. Here, because I have decimal part, so the 0 it's in the tenths, the 7 is in the hundredths, and the 1 is in the thousands. Now we're going to talk about PEMDAS using exponents. This you already learned it before, but I'm just going to make a quick revision that you have to know that when we have order of operation, the parenthesis is the strongest, then we have the exponents. So if you look at these examples, whenever you apply PEMDAS, you're going to reach the correct answer. As I always advise you, you can stop this video, solve these alone, and then check your answers. Okay, so now we reach the most important question where I need to write a in the form of a to the power m times b to the power n times c to the power p, where a, b, c are prime numbers. What we are trying to do is write the numbers as prime numbers to arrange the like bases together. So the first thing we're going to do is to write 36, 18, and 25 as prime numbers. Why? Look now what will happen. So I'm trying now to solve A. A is 36 to the power 2, but now 36, it's 2 squared times 3 squared. All of it to the power 2. Don't forget that we have times 2 to the power 2. Now 18, it's 2 times 3 squared, all of it to the power 3. Times 25, it's 5 squared, all of it to the power 3, minus 3. Now we're going to distribute the exponents. So it's 2 to the power 4 times 3 to the power 4 times 2 to the power 3 times 3 to the power 6 times 5 to the power minus 6. Now 2 to the power 4, those and 2 to the power 3 are like bases. So it's 2 to the power 7 times 3 to the power 10 times 5 to the power minus 6. So now we can say that a is written in the form of a to the power m times b to the power n times c to the power p. B and C, the same concept. So I advise you to solve them alone, and the answers, they are already written for you, so you can check them directly. Now, how can I simplify fractions using rules of powers? So as you can see here, we have 0.049 times 400 times 10 to the power minus 4 over 0.007 times 2 squared times 10 to the power minus 3. How can I think about this? The steps are very easy. Change all the decimal numbers into wholes. What I'm trying to say is here, instead of, let me change the color here, I'm going to use blue. So instead of 0.049, it's 49 times 10 to the power minus 3. Instead of 400, it's 4 times 10 to the power 2. 10 to the power minus 4, it's already in the whole part. Instead of 0.07, it's 7 times 10 to the power minus 3. And now, after doing this, you have to write all the numbers as prime numbers. So the 49, it's 7 squared. The 4, it's 2 squared. And all the rest are the same. Now you can cross out the like bases with exponents. So 2 squared and 2 squared, they cancel each other. 7 squared with 7, it's 7. Now what about the tens? You know that 10 to the power minus 3. I'm going also to change the color. I'm going to use orange. 10 to the power minus 3 with 10 to the power 2 with 10 to the power minus 4, you add them, right? So you're going to get 10 to the power, here we go, 10 to the power minus 3 plus 2, it's minus 1, minus 4, it's minus 5, okay? And also it's 10 to the power minus 5 up. Now down, what do we have? 10 to the power minus 3 with 10 to the power minus 3, it's 10 to the power minus 6. If you just switch their places, if you get 10 to the power minus 6 up and 10 to the power minus 5 down, you will get at the end 7 times 10. So the steps are very easy. Change all decimals into whole, then decompose all the bases into prime numbers using prime factorization. Move all the negative exponent to become positive, whether you move it upward or downward. And then you should use this rule, and then reduction by cancelling. So that was everything for our lecture. I advise you to solve all the exercises that are found in the PDF file and those that are in the video, and then start solving the worksheet.